Hello and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This is the last video in our treatment of multi-threading and parallelism. And in this video we're going to look at a very brief introduction to the Scala actors library. We're not actually going to use actors in the way that they're supposed to be used. We're going to look at them at this point just as a simple way of starting processes up in threads. There's a later chapter in the book, and so several playlists from now in the videos we'll look at actors and the actual actor implementation and how you can use the actor model of parallelism. But for now, all we're going to do is look at them as a way of spawning threads in a more Scala-like manner. So there is a scala.actors package, and we're going to pay attention to two main things. First is the actor object, and so the actor object has a method inside of it called actor, and you pass this method a body, which is a by name value that returns a unit. And what happens when you call this is it will take whatever code you pass into here and automatically spawn it off as another off in a separate thread. So to give you some idea of what the syntax looks like here, so if I import actors.Actor, what would be a reasonable thing for us to do here? Actually, I need something slow. Let's go ahead and define a fib function. This Fibonacci function is just useful because it's remarkably slow in order to do the calculations if you get n to be very large. Okay, so there's our standard Fibonacci, and what I want to do here is I want to do something like what I did before for I in, let's go though from 30 to 40, and so I don't need to count by anything. Print line fib of I, and close off the actor. Now, the thing to note here is that my prompt returned right there. So I can type things into here, oops, and I can make errors in it, while this was still going. So this was 30, 40, 50, 60, 70, 80, 30, 31, 32, 33, 34, 1, 2, 3, 4, 5, 6, 37, 38, 39, okay, 40. So let's try this again. And so I'm able to print another high in the middle of this. I'm just trying to prove here that this was actually happening in a separate thread. If I made this go from 40 to 50, it would be even more obvious. But this just, whatever I put into the body here, it winds up happening off in a separate thread. So this is a very easy way, even easier than what we saw before of spawning things in threads. This does not inherently make the threads any safer. So all of the precautions that we've talked about previously, you have to worry about here. And I have seen many students abuse this, where because it's so easy to spawn a thread, they will put this in their code in places they probably shouldn't, and the next thing you know, they've spawned 1,000 threads, and they're actually slowing down their code tremendously. In addition to the actor, so the actor is just like starting a thread and with a runnable. It doesn't return anything, it just goes off and does something for you. There is also a futures object, and the futures object has a method in it called future, and it also takes a body, which is a by name argument, but this by name argument returns a t. and it returns a future. Now this is not the Java util concurrent future. This is a scala.actors future, which is very similar as far as what it does, but the syntax is a little bit different. And as you could tell here, this is intended to return things. And so what do these futures do? Instead of calling get, because these are done in a Scala fashion, you just put parentheses and do the apply. So we can take one of our earlier examples. How about instead of doing calcfib with executor, with actor futures, we're no longer going to do that. I will do the 30 through 15. I don't need a actually, so what line should I delete here? Instead of this being there, I'm going to do actors.Futures.Future. Oops. And now this doesn't call .get. It is just doing the application, putting parentheses after there so it treats it like a function, and that gets expanded to f.apply. So if we call this calcfib with actor futures up here, and we run it, apparently my Eclipse has gone unhappy and it's not going to let me run this. Have to restart Eclipse, but not for this video. Anyway, this will do just what we had done before, but instead of using the executors, we are just spawning things inside of the actors futures. Let's real quick try to clean this project out and see if that makes this at all happier. Nope. Doesn't look like it. It does wind up printing out the values in a somewhat random order. Here the biggest one came down at the end. Okay, so there you can see it does exactly what we've seen before with everything. It just does it in a different way, and really this is much more the Scala way of doing things. So instead of having to create a class and put in either a call or a run method, you just pass something in that is passed by name, and that way you can put whatever code you want in here very simply. And it winds up being almost as simple as the parallel collections, but unlike the parallel collections, the futures are a little bit more flexible in what they do. So that's it for this video, and we'll move on to the next chapter.